All right, so we're going to practice. The first problem that we're given is linear. And so we have 6x plus 9y equals 2. And the way that they've set it up is you're supposed to go step by step. How do I know, first of all, that it's linear? Because my largest exponent is a 1. Okay, so if I were to solve this for y, which I'm fixing to do, I will get a linear equation. So step 1 is let's solve it for y. So I'm going to subtract 6x from both sides. So I've got a 9y equals a negative 6x plus 2. And then I'm going to divide everything by 9. So I get y equals, remember this 9 belongs to both sides, so negative 2/3 x plus 2/9. And that is my, in y equals mx plus b format. This was in standard form. This is in y equals mx plus b form, or slope intercept. All right. So we've done the algebra of it. Now let's do the calculus. I need to do a derivative. So the derivative here is a negative 2/3. And we're done. So again, what's the derivative? It's the formula for slope for instantaneous rate of change, or the formula for slope of the tangent line. So I did that. It's done. Now we want to implicitly take the derivative of this function, which means leave it where you have not solved for y. Okay, so the first thing that I want to do is take these derivatives. So the derivative of 6x, okay, is 6 dx. So you put the dx because you took the derivative of x. Plus, what's the derivative of 9y? It's 9 dy. What's the derivative of 2? Is 0. Okay, so step 1, what they did, okay, is they went ahead and divided everything by dx. So that went away, and there's your dx there. And then 0 divided by anything other than 0 is 0. Okay, so what you're going to see on this specific problem is 9 dy dx equals 0. Okay, now I personally don't like doing it this way. That's my I like following the steps that I gave you before. It's just a little bit harder, I think, to do it this way. All right, so that means I'm going to divide both sides, or sorry, subtract both sides by 6. So I get 9 dy dx is a negative 6. And now I can divide both sides by 9. So dy dx is a negative 6 over 9, which is the exact same thing as a negative 2/3. Okay, so basically we're just showing you, hey, I know how to do this. It works both ways. So now we're going to dive in and go. All right, so it is practice time. So I've got a 5x squared plus a y squared equals 4. Okay, so what I want to do is solve this, or differentiate implicitly. So I'm going to take this derivative, which is a 10x dx. Take this derivative, which is a 2y dy, and that equals 0. Okay, so now I want my dy's on one side, I want my dx's on the other. So that means I'm going to subtract this chunk over to the right. So I have a 2y dy equals a negative 10x dx. Okay, and now, because I'm a lazy math person, I would love to notice I've got to divide both sides by dx. I've also got to divide both sides by 2y. Okay, so I'm going to do it a step at a time this time, but I want you to notice this is going to become the denominator over here, and this is going to become the denominator over here. So I can kind of sort of just do it at the same time. So dy, divide both sides by dx, so it disappears here and appears in the denominator on the left, equals negative 10x over, it disappears from over here and becomes the denominator on the right. And when I reduce that, I get a negative 5x over y. So your implicit differentiation gives you a formula for slope of a tangent line or for instantaneous rate of change of negative 5x over y. Okay, so let's try it again. I have x squared plus 3xy plus y squared is 5. Okay, so immediately I notice it's going to be a whole lot messier for me to solve this thing for y. This is why we like implicit differentiation, because it helps us be lazy. So what's the derivative of x squared? It is 2x dx. Okay, don't forget your dx. On here, I'm going to have to do product rule, because I got variables times variables. So what I have is the first, which is just 3x, times the derivative of the second. So what's the derivative of y? It is 1 dy. You took the derivative of y, so don't forget your dy, plus the second, which is y, times the derivative of the first. So what's the derivative of 3x? It is 3 dx. You took the derivative of x. Don't forget your dx. So first times derivative of the second plus the second times the derivative of the first. And then what's the derivative of y squared? It is 2y dy. And all of that equals 0 because the derivative of 5 is 0. Okay, so here's where you want to organize. I want your dx's on the right and your dy's on the left. So he has a dy, he's going to stay. Okay, he has a dy, he's going to stay. I need to subtract him to the right. I need to subtract him to the right. Okay, so that becomes 3x dy plus 2y dy equals, subtract him over, so he changes signs. Subtract him over, so he changes signs. Okay? So now my dy's are on the left. My dx's are on the right. So you have a choice at this point, because I got multiple dy's, I got multiple dx's. If you cannot combine like terms, which you can't, because they're not alike, then factor it out. If you can't combine, then factor it out. So what do both of these have? Both of these have a dy. So when I factor out that dy, that leaves me with a 3x plus a 2y. Okay? When I factor out this dx, because these are not like terms, when I factor out this dx, I get a negative 2x minus a 3y. And now it's the exact same setup as it was up here, okay? So I need to get dy by itself, so I'm going to divide this off. So this was in the numerator on the left, it will be in the denominator on the right. This is in the numerator on the left, it will become the denominator. Sorry, on the right, it will become the denominator on the left. So divide both sides by dx. So dy dx equals, divide both sides by 3x plus 2y. So I get a negative 2x minus 3y over 3x plus 2y. So that is the formula for the slope of the tangent line, or the formula for instantaneous rate of change. Okay? So let's try it again. I have x to the 4/3 plus y to the 4/3 equals 9. And I want to differentiate by implicit differentiation. Okay, so I'm going to take this thing's derivative, which is 4/3 x to the negative 4/3 minus 3/3 is 1/3. Okay, 4/3 minus 3/3 is 1/3. dx, ignore that whole thing right there. Okay, so you took the derivative of x, so multiply by dx, plus 4/3 y to the 1/3 dy, because you took the derivative of y, equals 0. Okay, so I got two big old chunks. He's got dx's, he's got dy's. I want my dy's on the left and my dx's on the right, which means he needs to move over to the other side by subtraction. So that gives me 4/3 y to the 1/3 dy equals 4/3 x to the 1/3 dx, but you subtracted it, so it's negative. Okay? And now my dy's are on the left, my dx's are on the right. So I'm going to divide both sides by dx. So I get dy dx equals, I can divide both sides, divide both sides by 4/3 y to the 1/3. Okay? So 4/3 y to the 1/3. Okay? And that means I've got a negative 4/3 x to the 1/3 over a 4/3 y to the 1/3. And any number divided by itself is 1. Okay? So what did I get? I got a negative x to the 1/3 over a y to the 1/3. Okay, you can just leave it like that. Remember what that means is I've got a negative root, third root of x over a cubed root of y, third root of y. So that is what that means. All right, let's try it again. We've got 5x plus 3y raised to the 1/3 power equals x squared. All right, so be careful, because everything so far I've had it equal to a constant, and the derivative of any constant is 0. It's not equal to a constant this time. So just be careful, okay? So over here, I'm going to have to use power rule and some chain rule, okay? So drop your 1/3 out front, okay? So that gives me 1/3 5x plus 3y to the negative 2/3, okay? And now I need to multiply that by the derivative of the inside. So the derivative of the inside is 5 dx plus 3 dy, okay? Now take that thing's derivative. So I've got a 2x dx. So this is going to get just a little bit nasty. So right now I've got this times this times this equals this. So let's get rid of the fraction first by multiplying. So I'm going to multiply both sides by 3. So this is now a 6x dx. And that just makes it a tiny bit cleaner. Okay? My dx's and my dy's are trapped in these parentheses. So I've got to distribute this nastiness right here to both terms. So I'm going to have a 5 times the nastiness dx plus a 3 times the nastiness dy. Okay, so I'm just distributing. It's just a really ugly distribution. So I have 5 times 5x plus 3y to the negative 2/3 dx. Okay, so I just took this times 5 dx, so this times 5 dx, plus 3, 5x plus 3y to the negative 2/3 dy. So there's your 3 dy times this equals 6x dx. So I want my dx's on one side, which would be the right. So he's already there, leave him alone. I want my dy's on the left. He's already there, leave him alone. So I have a 3 5x plus 3y to the negative 2/3 dy equals negative, because I got to move him to the right. So I'm just going to write him first. 6x dx minus 5x plus 3y to the negative 2/3 dx. So I just left this here and subtracted this off. Okay? So in reality, you only have 3 big terms, or 3 big chunks. I got this one equals this one minus this one. Okay? So you can't combine these dx's. He's done. I can't do anything else with him. But I've got 2 dx's over here. So if you can't combine the like terms, factor it out. So I've got a 5x plus 3y to the negative 2/3 dy equals, and I'm going to factor out this dx. Okay, so I get a 6x minus 5x plus 3y to the negative 2/3 dx. Okay, so all I did was take this dx and pull them out and just rewrite what was already there. And now I've got my dy and my dx. So divide both sides by dx. So it disappears from the right and appears on the left. And divide both sides by this. So I have 5x plus 3y to the negative 2/3. So it disappears from the left and appears on the right. Okay, and I would leave it like that, because if I give you a point to evaluate, you can shove in your x's and y's and it'll simplify itself out. Okay, so I know it's messy, so we're going to come back with a final video.